we will see by which way we can use data science and analytics based toolkits for research based applications. In whatever domain you are working, like social networks, biomedical analysis, artificial intelligence, internet of things, software audit, software testing, cyber security, in almost every domain we have to analyze the data. If you are from industrial automation, in that case also we have to work on defect analysis, defect prediction, root cause analysis. If we are working on software audit, then we have to see which libraries or which APIs are creating problems. In segment of social networks analysis, we have to see which specific users are connected to which particular profiles or criminal patterns. So in almost every domain, we have to analyze the data in Internet of Things, in IoT based implementations. We have to investigate data or signals related to gadgets and sensors. In this session, we will see which platforms are available, different toolkits for multiple domains. First of all, before covering any particular demonstration dedicated to data science and analytics, I will show you one platform that was covered in previous session, Gen AI, because at that particular time, that particular toolkit was not loading. Now that toolkit is loaded and I will show you its demonstration. So you can see that this is Gen AI. In previous session we were discussing about local deployment of chatbot. Okay, so it is not only related to artificial intelligence, it can be integrated and associated with data science and analytics also. For example, I want to train my documents, I want to train my local data. In that case I can use Gen software. So in previous session also I have shown you this URL Gen AI, and this software is now working. So this I have loaded, and now you can see that it is working on my local system, and now there is no need of any internet connection. Even if I disconnect my internet now, I will be able to do exactly in similar way what we do in chat gpt or Gemini. For example, I am asking here what is machine learning. Okay, so you can see that whatever response I am getting here, it is, this particular response is not taken from internet, it is not taken from a backend online large language model. It is take, this particular response is retrieved from downloaded large language model. So complete LLM with its data is on my laptop, and now you can see that we are getting the responses, and its interface is very much similar to chat gpt. You can see that new chat. Okay, which particular assistant I want to integrate. So you can see hub, different models. So which model I want to download? For example, this Gen V 4 billion parameters, 2.3 GB. Okay, so all of these AI based models, Meta Llama, Gamma 2, these are having complete data set. Okay, if I want to download complete data of DeepSeek, you can see that. So I will simply click on this one, download, and complete DeepSeek will be on my laptop. But definitely in my laptop, in my system, resources should be sufficient. If I'm downloading a setup or a complete LLM of 400 GB, then obviously my hard disk should be supporting to that specific resource. So you can see that this one, thousands of models from different corporates. All of these I will be able to download. So which I want to use? So you can see download. So this Llama I have downloaded. It is having complete data and quantized in 2-bit, 3-bit, 4-bit. So these are used for, this is known as a quantization in data science, in artificial intelligence, in data analytics, Actually, these two terms are interrelated: artificial intelligence and data science. At the back end of artificial intelligence, we based chatbots, we have large language models. In large language models, what is actual block is data. Now, by which way we want to retrieve? We want to retrieve it with higher accuracy or moderate accuracy. So that is done with quantization, quantized in 2-bit, 3-bit, 4-bit. Generally, large language models are implemented with 32-bit. Okay, classically, most of the large language models, AI based models with backend data analytics blocks, these are implemented with 32 bits. But 32-bit model, that is very very resource hungry. Resource hungry means my cache memory should be should be sufficient, my RAM should be sufficient, my processor should be very very powerful to access that 32-bit model in my local laptop. Okay, if I am not using internet and locally I want to use DeepSeek or Chat GPT or Gemini, in that case 32-bit or 64-bit, it will be very very complex and lots of time will be there. So quantization is done 2-bit, 3-bit. If I want very quick results, then 2-bit. Okay, moderate results 6 bits. So these things we have to see. In Olama also, you will see different models. So these terms should be clear to us. When we download any model, it will ask for the quantization, 2 bits, 3 bits, 6 bits. For example, DeepSeek or Gamma. I want to download this Gamma complete model. So this particular architecture, okay, you can see that this one, it is giving us complete details. So quantization. Okay, so depending upon our requirements, we download that specific model. Now once it is downloaded on my laptop, then I can do anything without internet connection. Okay, now it is downloaded. For example, I am asking, okay, applications of machine learning in industry 4.0. So now it is running on my local laptop without internet connection. Okay, I can't show this demonstration without internet connection, otherwise this video call will be disconnected. Okay, but you can try it. Simply download and install Gen. Now for example, I am writing some abstract or I am writing some research paper and I am uploading my own data. In online version of ChatGPT, my abstract will be leaked out, my research topic will be leaked out. So if some other researcher is working on same topic, they will be having access to my topic, that this person is also working on that algorithm. Now if I want to hide my topic, I want to secure my topic, in that case what I will do, I will download Gen AI or Olama, and you can see that these are exactly same results. Okay, in same type of results will be retrieved, and no need of any payment. In chat gpt, if you will go for so many data extraction, so much data extraction after 10 to 15 attempts depending upon your tokens, chat gpt give you message to upgrade your account. Many times when we search very rigorously on chat gpt, then after some time it give us the message that upgrade your account or wait for 24 hours, wait for 8 hours. But in Gen AI, no need to wait for 8 hours or 24 hours. Okay, you can give any number of inputs, thousands of inputs, lakhs of inputs every day. And because it is local, it has nothing to do with internet, it has nothing to do with that particular cloud. It is locally deployed. So there is no limit on instructions, there is no limit on that particular content. So any number of content can be created, whether you are working on data science research or any other part. So you can see that this one. So Gen AI, which type of assistant you want to work out, hub, which platform you want to extract, you can simply download, and you can see settings. This one is the settings, and in that you will be able to work. If you want to import other models, you can work on that. For example, you want to import chat gpt also, you want to import Gemini, so these are also available. So you can see Llama, OpenAI, ChatGPT is from OpenAI, Mistral. Okay, otherwise locally you will be able to work without any limit. Okay, as just now we have discussed that if in chat gpt, in gemini, if you are very very active in finding the questions, in finding answers of some specific queries, then after some time it will give you message to wait for 2 hours, 3 hours, or 24 hours. But here in local deployment of chatbot, there is no worry. Your data is private, your content is private, each and everything is secure. Okay, Olama or Jan AI for local deployment. Now, dear participants, we will see some platforms related to data science and analytics which we can use for our research based applications. In this particular segment of data engineering and data analytics, we will discuss about different segments. Very first segment, that is related to academic and corporate research. What is meaning of that? For example, my area of research is medical diagnosis. In medical diagnosis, I want to work on a data set of X-ray images or ultrasound images or whatever it is. I need some data. Okay, my major task is to work on some particular data for my research work, whether it is academic research or corporate research. Academic, what is difference between academic research and corporate research? Academic research is done to achieve some academic credential for some degree or diploma. For example, master's degree, doctorate level degree. So that is academic research. Okay, in that case also we have to work on some particular data part. For example, my area of research is machine learning or deep learning. In deep learning, I want to work on object recognition. For to work on object recognition, we need some images for training. In machine learning also we need some data for training. If I am working on machine learning in industrial automation, machine learning in quality control, in industrial quality control. For example, I want to take a scenario of uh, quality control or root cause analysis in some automobile plant. Okay, so complete data set we can take from that plant at different parameters. Okay, participants from mechanical, from automobile engineering, they might be knowing better about it. For example, temperature, weather conditions, or some humidity. So 5 to 6 parameters we have taken, and whether that particular product was cleared or not, whether that particular assembly line was okay or not. So we want to see what was the root cause of failure of assembly line, what was the root cause or main cause of of obstruction in that specific plant. So that particular data, so that is corporate research. If we are actually working on some particular data that is taken from industrial plant, and its implementation is also for industrial application, that is corporate research. But if some particular data I am taking from industrial plant, from manufacturing plant, for example Tata Motors or Ashok Leyland or any other company, I am taking data, but that data I am using for my academic work. In that case it is not academic, it is not corporate research. In that case it will be considered as academic research. For example, I have taken data from Tata Motors or Maruti related to some failures related to some assembly line, but I am using it for my MTech degree or for PhD degree. That particular data, that specific research will be academic research. But if that output or that proposal I am giving to that company only for their upgradation, for their improvement, that will be corporate research. Okay, so these things should be clear: academic research, corporate research. Now major thing is that now the actual task will come to picture here, from where we have to take this particular data. If we are working on some particular domain like data analytics, like academic research or corporate research, or data engineering task. In that case, from where we have to take the data? If my area of research work is machine learning, deep learning, reinforcement learning, or even generative AI, from where I will collect the data? Obviously, companies or corporates will not give their data. Okay, just now I have given you one example that, for example, I have taken data from Tata Motors, but that data, uh, uh, after taking that data with analysis, I am using it for my PhD. First of all, this point should be clear that Tata Motor will not give me data. This is very first point. Even they will not give data to their employees also, because whatever data is available with that company, that is private, very very private data, very secure data. Okay, it is never leaked out. Even if it is copied by some particular person, some internal person, internal employee, that will be an attempt of cyber security breach, that will be an attempt of cyber attack. Okay, why we are discussing this point in data science, why we are discussing this particular thing in this specific topic of data engineering? If our area of, in whatever area we are doing research, whether it is corporate research or academic research, first of all, we should be clear about the source of data set. This is very very important, and this is the very first step in any implementation. Whether you are working on data science, data engineering, or AI/ML, deep learning, in whatever domain you are working, very first step is to fetch the appropriate data set. Now there are two type of data sets. One is benchmark data, second is self collected data. And in this very first step, there are lots of confusion, specifically in new researchers. Why there are lots of confusion in new researchers? You might have seen whenever whenever some researchers start their PhD or start their MTech master's level, they have lots of passion about their research work. They will do this thing, they will perform that type of implementation. It will be a social contribution, it will be contribution to the nation, it will be contribution to the society. But after some time, that particular thing, that passion, come to the reality that we have to work as per the guidelines of UGC, as per the guidelines of that specific governing body. Now, I will give you one example. It will be more clear with that. For example, my area of research is medical diagnosis, and I want to work on X-ray data set. My data set is X-ray data. Now, just because of my passion, because of my interest, I want that I will take data of X-ray images from my own sources. I will take genuine data of X-ray images. From where I will take genuine data? From AIMS, from PGI, from medical labs, from path labs. So many hospitals are in my contact. I will contact my doctors. I will contact some friends. They will give me actual X-ray images of patients, of Indian patients. This is known as self-collected data. Everybody knows that if I am collecting my own data from own sources, it is self-collected data. This is one scenario of medical. For example, some other person, that person is working on agriculture domain. They want to propose some new technique, some new solution to agriculture domain, and they are very passionate about their research work. They want to collect data from Ministry of Agriculture, from Department of Agriculture or Department of Forest, just to show that they have done genuine work. Genuinely, they are working on some actual data. One point we should be very much clear that for academic research, in most of the academic research, self collected data is not allowed. It is not allowed for academic research. In case of academic research, academic credential based research, we have to work on benchmark data sets. This is very first point in case of data engineering, machine learning, deep learning, or any task related to data science or that is having some data. Loads of platforms available from where we have to take the data set. So you can see this one. So I'm repeating that point. For academic research, whether it is master's level or doctorate level, generally I'm not saying that it is 100%. Okay, exceptions may be there, some exceptions may be there that you can take your own data, but in most of the cases self collected data is not allowed in academic research. We have to collect data from benchmark sources. These are benchmark sources, IEEE data port, and so many other, UCI machine learning repository. And along with UCI machine learning repository, Kaggle data sets. So you can see that data set. So here you will find so many data sets. For example, my area of research is heart disease. In that case, I should take data from Kaggle. These are benchmark data sets. What is meaning of benchmark data? Which is already tested by the scientists, by data scientists, which is the data sets which are already analyzed on multiple parameters. Okay, so for example, my area of research is signal processing. So in that case, I will take data from IEEE data port. These are, this one is the source of different data sets. So you can see that this one in multiple domains. If I want to work on COVID-19, so COVID-19 data set is also available here, so I can download it. Okay, I can't take these data from own sources. For example, my area of research is arthritis or cancer. Just because of my passion, I think that I will take data from PGI Chandigarh, from AIMS Delhi. So many AIMS are available in different states. Or many times we have seen that new researchers discuss this thing that if data is not available, if genuine data is not available, then we will file RTI. With RTI, they will have to give the data, and on that RTI based data we will do research. It is not allowed, it is not acceptable. Why? Because there is no authenticity of self collected data. Why there is no no authenticity of self collected data? Because there is complete scope, there is all scope of manipulation in self collected data. In benchmark sources of data sets, there is no scope of manipulation. For example, my area of research is student assessment. Okay, my I want to take a data related to student performance, and I want to propose some solution to Ministry of Education. So I can take data from here, and whatever algorithm I am implementing, for example, classification, regression, clustering, whatever I am doing, taking that particular data from here, and my accuracy is 99%. In that case, RDC panel or DRC panel, whatever it is, they can say that, okay, download this data in front of us and now perform your implementation. So I can't change this data set. Okay, for example, this one is data, and so different parameters are also given. Okay, not only this one. For example, I am working on geospatial data on some particular data related to satellite. So all data sets are available and these cannot be manipulated. But in case of self collected data, you can see this one. For example, we have taken self collected data. In case of self collected data, there is a scope of manipulation. For example, I have taken data from my own sources, from ministry, from RTI, or my own sources. In that case, for example, I am stuck at 85% accuracy. My area of research, my algorithm is deep learning algorithm. In deep learning implementation, I am stuck at 85% accuracy, or suppose 90% accuracy. Everybody knows that in 90% accuracy or even in 95% accuracy, work will be rejected. Okay, in machine learning, 95% accuracy can be accepted. But if I am proposing deep learning algorithm and I am giving my results with only 92, 93% accuracy, 8% error, work will be rejected. So if data set is collected by my own sources, in that case, what I can do to improve my accuracy? For example, my algorithm or my implementation is already fine. I am confident that my algorithm is okay, my coding is okay. This data set is creating the problem. So in that case, self-collected data can be manipulated because there is no proof, there is no evidence from where we have taken data. For example, I have taken 5,000 images of X-ray from multiple sources. Just to improve the accuracy, we can Photoshop the images. We can go for Photoshopping. We can go for changing brightness, contrast, changing some pixels, because nobody knows that what is actually inside these data sets. So that is the major problem in self-collected data. There is scope of manipulation. If you have taken data from medical labs, from ministry, from anywhere, from your own sources, from copy paste, from copying from multiple sources, which is having no online record. Okay, major thing is that data set which is having no online record. In that case, who knows whether this particular data is genuine or not? So in data science, engineering, in data analytics, this is very first point all of us for academic credentials must take. In most of the cases, not 100% cases, in exceptions, certain exceptions can be there where RDC panel can say that okay, you can take self-collected data. Okay, but generally we have not seen such cases earlier. For testing, for validation, for a prediction, you can take self-collected data, but for training a data set, for training a model, training AI model or data science model, we can't take self-collected data because there is a scope of manipulation. Okay, for prediction, if you want to go for prediction, in that case, you can take your own data from anywhere. It doesn't matter because we are only predicting on that. Okay, but for training, we have to take these data sets. So these links I have given in this presentation, Kaggle data sets, everybody knows Kaggle, GitHub, because these are having, these platforms are online available and there is no scope of manipulation. For example, Uber data analysis, okay, or student performance data, DNA classification, whatever it is, thousands of data, not thousands, millions of data sets available, so many sources available. Any of these we can download and we can present our research work, and we can say confidently that okay, you can download this data now and see my implementation, it is giving this much output, okay, this much accuracy. But if I'm taking my own data, in that case, first of all, they will question on my data, from where you have taken this data, is it genuine or not, okay, how much manipulation you have done. So there may be question that uh, you have done manipulation in data set to improve accuracy, you have done overfitting. So many questions can be there, but if we are taking data from these sources, in that case there is no scope of questioning specific to data sets. So if you are working on the medical domain, then NCBI portal is available. You can see NCBI portal for data related to proteins, DNA structures, genomes, so many platforms. So you can see that different links available, data and software and DNA, RNA. If your data, if your research work is related to some disease, to some fungal infection, to some bacteria germ infection, okay, to COVID, or to some particular protein structure, in that case you can adopt this portal. Up to this point, is it clear to all participants? Kindly confirm. And are you getting whatever we are covering here? Kindly confirm in chat window. Up to this point, whatever we are covering, is it clear to all of you? Okay, so now we will see some use cases. We will see some real world scenarios. Okay, I will show you some real world scenarios related to data science and analytics. And before that, very quickly, I'm showing you one point, because this point is also a point of question many times by the participants. Okay, so this is another portal, PCIR. This, all of these links I will share to all of you at end of the session, so that you will be able to work. Okay, if you need some data related to MRI, images, you need some data related to ultrasound or some specific CT scan. So you can see that patient contributed image repository. These are pre-tested data sets. These are data sets already tested by the scientists, by the data analysts, that there is no manipulation and these data sets are okay. Okay, so you can see that this one, shoulder, brain, abdomen, heart, different files, so we can download it and we can train a machine learning or deep learning model. Now one point that is generally addressed or generally asked when we discuss this point about data sets, many times researchers ask that how to create or how to make our own data set as benchmark. For example, I have collected data from my own sources. I want to use it in my research. Along with that, I want to make it considerable as benchmark. There are certain guidelines that we have to follow, that we have to adopt. Okay, so these are four guidelines which we have to adopt to make our data in benchmark category, to show that my data set is also genuine. For example, I have collected data from medical lab, from some hospital, or from agriculture department, from meteorological department, anywhere we have collected data from some industry, from some company. We have collected data and now I want to use it for my research, and I want that my panel, my university should consider it as benchmark. In that case, very first condition is it should be publicly available. It should not be private. Very first condition. You have to upload it on online portal, on GitHub, on Kaggle, on IEEE data port. They will check your data. They will verify authenticity of your data and its different constraints, in its different patterns. They will analyze, and after that, they will upload it, and it will be publicly available. This is very first condition. Second condition, data set must address a specific problem. It means your data set should not be all rounder. Data set should not be all rounder. All rounder means, for example, I have collected a data, and on that data clustering can be implemented, regression, classification, ensemble learning, decision tree, neural network, support vector classifier, convolutional neural network, time series, everything can be done. How it is possible? It is not possible to perform everything on a data set. If my data set is temporal data, if my data set is a time series data, in that case, obviously time series method will be implemented or LSTM will be implemented. Okay, so your data set should not be all rounder. It should not be generic. It should be specific, that this data set is only for classification. This data set is only for clustering. This data set can be used for decision making or neural network. So particular problem can be solved. Okay, or two to three problems. I'm showing you one sample also. For example, UCI machine learning repository. Okay, in UCI learning repository also, you will see particular problems are given. Iris data, it is only for classification. Heart disease data, it is for classification. Wine quality data, it is for classification and regression. Okay, so these are not all rounder data. It is for classification and clustering. You will not see any data here in which classification, regression, clustering, decision tree, this, that, each and everything is done. Okay, if your data set is all rounder, it means this data is not benchmark. This can't be used for research. After that, preferably standardized, standard deviation based. It should be uniform, consistency should be there. Okay, statistical formulations should be used, particular standard deviation, variance, these should be used. It should not happen that data is abruptly varying. For example, data set is related to males. One record is of year of age group 18 years. Second of 79 years or 70 years. senior citizen. It should not happen. So standard deviation in in parameters, in attributes. If your data set is related to males or females, it should be dedicated to particular category. Okay, this age group, this gender, this disease, this height, this weight. Okay, only slightly variation can be there. Okay, very slight change can be there. It should not happen that one few records are related to children, few records are related to senior citizens, few records are related to some other age group. So particular guidelines should be followed. If your data set, your collected data set is following all of these guidelines, in that case you will be able to present your data as benchmark, and then you will be able to work on your data sets. Okay, so this particular presentation I will share to all of you so that you will be able to work at end of this session. I will share now, dear participants. I'm covering some platforms, some cloud based platforms which we can use for data analytics, for data integration along with artificial intelligence in agriculture and forest. So these are some use cases. Okay, in continuation of the previous topic of artificial intelligence, we will see in forest management, in agriculture, in geospatial data analysis, by which way we can use some platforms. Some online platforms are available. Okay, for biodiversity protection. So for if we want to work for data analytics, if we want to integrate AI with IoT and data analytics for applications like disaster management, like fire detection, okay, classification and extinction recognition. For example, some data we are having related to forest animals or some particular animals in a national park. So how to predict that in this much time there will be extinction, or these animals are going to be extinct, or they will disappear after n number of years. You might have seen many times such predictions are given by agriculture scientists related to some plants, related to some trees. In forest also, different experts, different scientists work on this particular segment, that this animal or these creatures will be disappeared after n number of years completely. So by which way we will be able to work? So all of these research topics are related to data science and analytics along with artificial intelligence. Analytics of movement, climate change effect, whatever climate is there, and by which way it is affecting the animals and creatures. For that, for such type of implementations, certain forest reserves, some certain tiger reserves and national parks, they have already implemented AI and data science based implementations. And you can see that in Pench Tiger Reserve in Maharashtra, it is already implemented. Virtual boundary wall. There is no physical boundary wall in this particular national park, in this particular tiger reserve. Okay, virtual wall. Okay, so if we want to work on such type of scenarios, so these are not only related to IoT, these are not only related to artificial intelligence. These implementations are a merger of AI, IoT, as well as data science and engineering. Now we will see some implementations, some platforms which we can use for data analytics related to agriculture, related to some specific domains of geospatial data. Okay, EOS is one of that. Okay, geospatial data analysis, satellite data analytics, this one. Okay, so which particular part we want to analyze? Okay, if I want to work on agriculture domain, if I want to work on some particular domain like forest area, so we can select this one. Okay, Another application, so global forest watch, I will show you real time data analytics also, by which way you can make use of cloud based tools. All of these are cloud based platforms and freely available. Forest monitoring, if your research work is related to forest monitoring, geospatial data analysis, satellite data analysis, and with these platforms you can propose very good research projects to government agencies. Okay, because nowadays you might have seen the ministries and government agencies are supporting sustainable development, okay, environmental protection. So for example, I want to give some proposal related to some particular land, related to some specific location. So first of all, I should be able to analyze this data. So you can see global forest watch, and in that I want to analyze some specific location. How much deforestation is there? I want to check deforestation or fire uh, incidents at a particular point. So any location you can see in your state, in your city, or nearby your city, whatever forest area, whatever agriculture land is there, you can analyze it. So as soon as I will select, so just for demonstration, I'm taking any location randomly. So for example, this location, okay, any location. This is completely free. For example, this one, analyze. I want to analyze it. So in online version, we are able to analyze the data. If we are working on some particular research paper, so in that also we will be able to propose. Okay, for example, for some research paper or for some research project, we need to give some particular data set. So that data we will be able to take from this platform. So any of these we can explore. So first of all, okay, so simply, so it is giving us the view of Google Earth, and now we will be able to this one. Okay, just randomly I have selected something, some point, and data will be extracted, and after that we will be able to analyze. Its reports will be generated. Okay, depending upon that specific location. Okay, detection of single alert system. So up to now you can see that there is no sensor attached. So what we can do, we can propose some specific sensors at particular location. If we want to capture this particular data in form of JSON file, that can also be done. Along with that, predictive analytics, that is also available. So you can see that this one, high confidence detection by single alert system 36. So at this point it is implemented, and analysis part, land cover, primary forest, tropical trees. So this complete data set is available here. So you can see that this one. So for research papers, so for different types of analytics, so natural forests, this one, land cover. Okay, I am not using any paid account. I am not using any paid variant. With only free variant, I am able to analyze a particular location. Okay, land cover, climate. climate data analysis, tree biomass density. Okay, so for agriculture domain, for forest management, for sustainable development, so you can see that CO2 absorbed, CO2 released. So this particular data I want to present. For example, you want to propose some algorithm, some approach for decreasing global warming, for optimization of certain pollution aspect. So in that case, first of all, you should be having this particular data. Okay, so you can see that this one, climatic data, forest greenhouse gas emissions. So any location throughout the world you can identify, you can evaluate this one. Okay, global forest watch. Okay, if you want to save in a particular file, that can also be done. And some other tools, very quickly I will show you some other tools also. For example, you want to work on this one, ArcGIS. Okay, ArcGIS, map viewer, real time data analytics. Now you can see this one. So, and this particular data is real time data, dynamic data. And if this is dynamic data, real time data, and I want to use it in my work, in my publication, in that case, very less probability of plagiarism. Why? Because this particular data is dynamic data. Okay, it is not fixed data. In same way, this one, ArcGIS, we want to analyze some particular point. So geospatial data analysis, this one, and GeoJSON to extract real-time coordinates, to extract real-time coordinates and segments from any location. So you can see this one is Earth view, GeoJSON. So I want to analyze, I want to draw one diagram, I want to draw uh, a particular area, and in that particular area, how many forests are there, how much forest area is there. Okay, I want to analyze it. So for that, I will use this platform, online platform, and freely available. This is GeoJSON. So I first of all I will move to this location India, and now zoom, and it's come online. Its online palette is given. This toolbox is given. First of all, I will move to some location. So this is Kanha National Park, and in this particular national park, if I want to see forest area, I want to see some green area, or some location where is some specific incident of fire, forest fire, or anything, or whatever location is dense, whatever location is having less population. So in this way, so you can see that draw polygon, draw rectangular polygon. So at right hand side, this will change as soon as I will select. You can see that this one, select this. Now for example, this is just random, just randomly I am doing it. Click. As soon as I have clicked, this particular coordinate will change. At right hand side, these coordinates will be modified. Okay, in tabular, in JSON data, if I want to see how many forests, how many points are there, how much agricultural land, or how much dense land is there. So in that case, what I will do, I will copy this code, I will copy this particular data in Python script. So I'm opening Google Colab. In Google Colab, I want to use, so this is in same way. If I want to work with this one, so you can see this. So which location I want to analyze. Okay, as soon as I have selected, Now this particular, so you can see that I can save, and these coordinates, whatever coordinates are there, I will copy, and after copying it, so you can see that these are copied. Okay, and once it is copied in Python code, in Python we have a library GeoPandas for geospatial data analysis. Okay, so you can see that geospatial data analysis, simply give coordinates for that particular points, and it will generate the detailed report. Okay, so pip install geo pandas, and after that we will be able to find out the forest area. So whatever location we have taken, whatever code we have taken from this platform, now you can see this one: forest A 108 square kilometer, and forest B 9 square kilometer. Okay, or 9 kilometer square. In same way, any other location, any other point, you will be able to explore from throughout the world. So this one, if I want to see distance, for this one is distance, for example, from this point to this point, how much is distance. So you can see this is 118 kilometers. Okay, now I want to see this one: 149.51. So I'm zooming it so that you can see it clearly. So again, for example, I want to see some distance, so click, and this one 34.66 kilometer, 21.54 miles. So on completely online. Okay, this specific location. So many tools available, multiple applications available, which we can use for data analytics. Okay, so these links I have given in this presentation, which you can use for GeoJSON, whatever code you have taken, and you will be able to analyze. Or you can use Global Forest Watch. This one is Global Forest Watch, and this one. So on different online tools we can explore on whatever domain we are working, whether it is medical domain or geospatial data analysis, forest, agriculture, education, learning. Okay, so you can see this one: real-time data analytics dashboard. Its complete report will be generated. You can see that these plots will be generated. Whatever options we have selected, depending upon that, we will be able to access the graphs. Now you can see this one, these graphs. Okay, otherwise, to work on such type of data, we have to explore multiple platforms. Okay, but from this you can work on very easily. Okay, so you can download this data, it is freely available. Okay, or you can use this one, EOS data analytics. Okay, EOS data analytics, global forest watch, or you can work on that one. Okay, so you can see this one. So if I want to analyze a particular data, okay, a specific location, so on mouse over you can see this one is cloud. Okay, wherever crops are there we can see. So you can see NDVI, dense vegetation. Okay, vegetation index, sparse vegetation. If area of work is related to agriculture, you can see that this one. Soil, whether what is soil quality. So without deploying my own sensors, otherwise I will have to put my sensors, and obviously as a researcher or as a common man, how much it is difficult to place sensors, to purchase the sensors. Okay, rather than purchasing sensors, we can simply use the satellite. Okay, so we can see if I want to use some particular location, this one. Okay, measure distance, this one, from this to this one, 0.43 kilometers, 0.77 kilometers. Okay, and on mouse over we will be able to see NDVI, that is known as vegetation index, whether this soil is fit for vegetation or not, and its predictions are also given. You can see that currently it is giving this particular data. If I want to see its prediction uh, to next month, that can also be implemented. Crop info chart, I want to generate its chart. So simply select the agriculture land, and that specific data can be generated. So till September 9, what is the data? So prediction is also given, predictive data analytics. So you can see that how much area is better for vegetation, how much area is having good quality of soil. Okay, we can download this specific data set. Okay, crop monitoring or agriculture land monitoring. So depending upon your use case, you will be able to take that scenario. Zoom out. And, different parameters, weather details, analytics, analytics of weather. So you can see the complete report, and it is plagiarism free data. On which parameter we want to work? Data manager. Okay, we want to export this particular data, that can also be done. Okay, if we want to upload our own file. Okay, forecasting, if we want to go for forecasting. Okay, forecasting on humidity, cloud, wind, precipitation. And you can see today 27th August, and tomorrow's, so next, so till September 9, and we can expand it. So with real-time data analytics from satellite and artificial intelligence based models, it will go for prediction what may happen in future, what may happen at a particular timestamp. So you can use these platforms: EOS, Open Weather Map for weather applications. Okay, if you want to go for some data analytics related to weather forecasting, this particular API is also free. So you can see that. So as soon as you will create account, and it will you will be able to work on very good research projects. For example, weather data, hourly forecast data, climatic forecast, road risk data, okay, solar irradiance data sets, okay, dynamic data fetching, statistical weather data, okay, precipitation, fire weather, relief maps, air pollution. So on on which particular segment you want to work? Ultraviolet, geocoding. Okay. So multiple tools available for data science and analytics. Major thing is that first of all we should identify in which area we are working, whether forest, agriculture, weather forecasting, or medical domain, education, learning. In each and every segment, different toolkits available. Okay, so these links I have given in this presentation. You can explore. I'm sharing this presentation to all of you so that you will be able to work on it. These links I'm giving, by which way you will be able to work on very effective projects. And one of the very and one more platform for real-time data analytics, that is Forest Stat. Okay, for geospatial data analysis, for forest fire detection. Okay, so this one, satellite earth observation and AI for forest fire prevention, real-time data analytics on forest fire. On agriculture, I have shown you EUS. So it depends on uh, your research objectives on which you want to work out. Okay, this platform also gives you complete data set related to different locations. Okay, and you can propose solutions to government agencies, to NGOs, to corporates, so that uh, particular solutions can be implemented. Okay,